Okay. Today we're going to look at right triangles. So, before we look at how to figure out if they're congruent or not, we got to figure out what are parts of a right triangle. So, obviously we got a right angle here. How many right angles can you have in a triangle? One. Because if you have more than one, is it a triangle? No, because triangles add up to 180 degrees. If you have two 90-degree angles, there's nothing left for the third angle. Okay? So the other two angles are acute angles. Okay? So they're really good looking. All right. Now, what's the side opposite the right angle called? What's the side opposite the right angle called? The hypotenuse. That is very important for you to remember today. Because if you don't know what a hypotenuse is, you're not going to understand what's going on. So the side opposite the right angle is a hypotenuse. The other two sides are called legs. This is a leg, and this is a leg. So you have a hypotenuse and a leg and a leg. Now, the Pythagorean theorem says that the hypotenuse squared is equal to the sum of the squares of the two legs of a right triangle. Okay? Or if we nickname the hypotenuse C and the legs A and B, C squared equals A squared plus B squared. Pythagorean theorem. We've seen that before, and it's right up here. Okay? So, we have two students in class, Seth and Jay, and they wrote explanations on why these two triangles are congruent. Seth said, well, if we have two pairs of congruent sides, I know that AC is congruent to FD and AB is congruent to ED. And we have a pair of right angles, so angle C is congruent to angle F, so then by side-side angle, they're congruent. Is Seth good on that? And the answer is no, because of this. What did I say about side-to-side angle? It makes an angle side-side out of you, right? Because you can't prove side-side angle. So side-side angle is not a way to prove triangles congruent. So then there's this person by the name of Jay. So Jay says, well, the lengths of BC and EF are 3 inches. And how would she know that they're 3 inches? Well, by the Pythagorean theorem. C squared equals A squared plus B squared. The hypotenuse of each of these is 5. One of the legs is 4. So 5 squared equals 4 squared plus B squared, or 25 equals 16 plus B squared. Subtract 16. B squared equals 9. B equals 3. Okay? So for both of them, since this is 5 and this is 4, these are each 3. So then this is congruent to this is congruent to this, and this is congruent to this. Does Jay's answer work by side, side, side? And the answer is yes. It works by side, side, side. But there is a quicker method than to try to figure out the Pythagorean theorem than side, side, side if you have a right triangle. Okay? When any two pairs of sides are congruent, you can show that two right triangles are congruent. So you have to know the correct sides. Okay? If you have the two legs congruent to each other, and you know it's a right angle, then you can say they're congruent by side angle side. Okay? Everybody with me? That's side angle side. If you know the hypotenuse and one leg, and you know it's a right triangle, then there's a special theorem called hypotenuse leg. Now you might say, well, Mr. Bierschbach, that's side-side angle, and you're going to make an angle side-side out of yourself if you try to use that. I'm not saying side-side angle. because it's a right triangle, and side-side angle only works in right triangles. That's why we don't call it side-side angle. We call it hypotenuse leg. And the hypotenuse leg theorem is this. If you know the hypotenuse of two right triangles and a leg of two right triangles, because they're right triangles, that's enough to say that they have to be congruent to each other. So it's hypotenuse leg. So would these two be congruent by hypotenuse leg, yes or no? Yes, because we know the hypotenuse of each. They're a right triangle when we know a leg of each. So yes, they are congruent by hypotenuse leg. Is this enough to say hypotenuse leg? No, because you know the hypotenuse of each. You know one leg of this one, but you don't know either leg of this one. So if this is 10, this could be like 7.94, and this could be 6.02, and it could make 10 or something like that. Okay, so that doesn't work. You need a little bit more information. So, all right, phone is ringing. Hello. Nope. Nope. Okay, sounds good. Yep, bye. All right, so here we go. Zoom, zoom. All right, it says write a proof to show this triangle is isosceles, because we only know that AE is congruent. Hi, Mr. Bierschbeck. AE is congruent to AD. We don't know that AB is congruent to AC yet. So what we see, and this is a classic proof. See how long it is compared to the ones you've seen so far? Okay, sometimes it'll get a little bit longer and you have to go step by step by step. So this matches this. This matches this. These are in the given statement. So what's the reason for saying that? Given. Okay, that FD is perpendicular to AB and that FE is perpendicular to AC. So we've already established we got some right triangles here. Okay, we've got some right triangles here. All right, so since it's perpendicular, we have 90-degree angles. That's the definition of perpendicular lines. Okay, so if they talk about perpendicular in one statement and they talk about them being 90 degrees, that's the definition of perpendicular lines. Okay, all right. Then if we have 90-degree angles and they talk about right triangles on the next step, that's the definition of a right triangle. Okay, so we're defining certain things. So it took 3 steps to say, hey, we've got right triangles here. Then it says AE is congruent to AD. How do I know AE is congruent to AD? Do I see it anywhere? Besides the picture being marked, is it somewhere else in the directions? It's in the givens. Okay, come on. It is right here. AE is congruent to AD, so that must be given. AF is congruent to AF. This is a super important one that will come up a lot in here. AF is congruent to AF. It is on top of itself. So when it's on top of itself, it's like a mirror reflection or the reflexive property. The reflexive property. You don't have to say of congruence in my room, but that's what it officially is. Okay? All right. So I know in this triangle is congruent to this triangle now because I know the hypotenuse, because that's the side opposite the right angles, and the leg of each. So FEA is congruent to FDA by hypotenuse leg. Now, EF, in the next step, they say EF is congruent to DF. Why is EF congruent to DF? Well, they're parts of two triangles that are congruent. What types of parts? They are corresponding parts of congruent triangles that are congruent. Now, once you prove triangles congruent, the next step almost always is this. Because you want to use the rest of the triangles, the other parts, to help prove other things. So if there's any steps after two triangles being congruent, then it's generally CPCTC. All right. Now, if we know this is a right angle, what's this going to be right here? This one's going to be a right angle. And they should have said something about these being right angles and these being right triangles, but they didn't. But FC is congruent to FB because that is right here, so that is given. And now I have a right triangle here, right triangle here. I know the hypotenuse of each. I know a leg of each. So again, it's hypotenuse leg. And then once I know that, I can say this angle here is congruent to this angle here. Those two angles are CPCTC, corresponding parts of congruent triangles that are congruent. And then in the isosceles triangle theorem, it says if this angle down here is congruent to this angle right here, then this whole side here is congruent to this whole side here. So AC is congruent to AB by and it is the isosceles triangle theorem. You don't have to say converse for me when it comes to a test if you would ever have to do this on test. Just so you remember the isosceles triangle theorem. So triangle ABC is isosceles because of the definition of being an isosceles triangle. Okay? So 12-step proof. Okay? 12-step proof. So you might have some proofs today. Okay. So why are triangles congruent? Well, you got side angle side that they could be congruent by. You could have angle side angle that they could be congruent by. You could have angle angle side that they're congruent by. And you can have hypotenuse leg. Okay? Those are 4 different ways to prove right triangles congruent. Okay? The first 3 we've already had up until today, and now the 4th one is hypotenuse leg. Okay? So, there you go. Yeah, there we go for right now.